Hello everyone, today we're going to be jumping into Blender and creating an STL file that we'll actually use to print a box that will be outside to hold our Raspberry Pi and our components. We'll use that box that we print to waterproof the electronics, make sure that they don't get wet when they're rained on, and that's about it, so stay tuned. Alright, so we've got the Raspberry Pi and the breadboard here. We've got to create a box that can be outside, and that means it needs to be waterproof, it needs to be weatherproof, that means heat resistant, and not something that is going to be able to break and be brittle. So that means that we're going to have to use an ABS material on our 3D printer to actually be able to print a box for this thing. So in order to start getting the box ready, we need to get a few measurements. So we've got our little millimeter precise measurement tool here. Our box doesn't have to be super precise, but this will give us an idea of what the dimensions need to be. So we'll go ahead and get these measurements quick. Let's just say, let's print the box at 60 millimeters width. And then let's go ahead and print it at 90 millimeters at the other end. And then we're going to want to leave some room for our connections to actually come into the box. We'll do that, give it some height. So let's say we go to the bottom of this thing. 60 millimeters for a height is probably going to be a good dimension. Now, that's going to be the very top of the box. We're going to need a little bit more room to actually put a lid on it. So let's say the total is going to be 70 millimeters in height. So those are the dimensions that we'll use to build the box, and let's go ahead and create that in Blender. We're going to need to create a few components based on the measurements that we took. So the first component that we have is a cube, and we're going to make the item dimensions for this cube set to what we had measured. So 90 millimeters, 60 millimeters, and 70 millimeters for height. Now this is just the interior of the box, and because it's the interior of the box, we actually need to create a second box that will be the exterior of the box. So we'll go ahead and copy this guy and paste. On the second box, this will be the exterior walls. So we know that the X and the Y are 90 and 60, but if we want to give the X dimension, let's say 5 millimeters of extra room, we're going to need 5 to 95 and 65. And that allows us to have 5 millimeters on the edges here for the interior versus the exterior of the box. Now that doesn't quite look like it's going to be enough room, so I'm going to go ahead and increase that. Let's make it 170. So that should give a nice total of 10 millimeters of room on the edges. Now the reason I ended up doing that is because we needed some extra rooms to actually put in some pilot holes for some screws. So, and then additionally, we're going to have to make the second box the same height with an extra 10 as well. So we'll do 80 for the height. So now we've got our first box here sitting on the inside of that guy. And our second box will act as our exterior walls. Let's go ahead and align those Z faces. So now we can do a cutout for our cube. So select our walls, add a modifier, we'll do a Boolean. Select our first cube. We'll go ahead and make this cube just barely visible with just showing the wires. So visibility. Let's make it wired. So now we can see that the cube 1, which is our exterior box, with the cutout of our original cube, this is what it should look like. Now we're going to need to put a lid on top of this guy, so let's go ahead and create another cube. We're going to have to make the cube the same dimensions of this guy, so x 100, y 70, and then z will make 10. So real quick, x 100, y 70, x 100, y 70, and z 10. Grab the z, align the face, let's go ahead, grab z, align to the face, and there we go. Now we've got this lid that will sit on top of the other box, and then we've got to drill out some holes for it. So let's go ahead, turn snap off, move this guy just over to the side so we can see, and add some cylinders. Now we measured some of these screws that we've got. The diameter of this cutout we're going to do is 2 millimeters, and the height of this screw we'll say is 5 millimeters. So we need to create a cylinder, keep x and y 2 and z 5, and this will be our cutout for that little screw and inside of our model. Now, this probably isn't going to work if we have a large lid like that. So in reality, let's go ahead and make the Z on that lid 2 millimeters, so that way the screw will have about 3 millimeters that it can actually sink into the body. So let's make 3 copies of that guy. Move the X back over and realign these guys. So let's align the Z's. Let's align the X. Alright, now we've got the lid sitting back on top. Grab one of these guys. Go ahead and align the Z. Go ahead and align the Y. And align the X. We'll go into X-ray mode to make sure that we've got enough room. And let's try to go ahead and center this guy. So we'll take the cutout and we'll just manually adjust the positions. So let's add 2.5 and add 2.5. And then let's take the Z, turn off snapping, and we'll sink this guy up 5 millimeters. There we go. Now, let's just see how it aligns. It's not quite in the center. So I'm going to move this guy back over. Let's just say, okay, 47 looks good. Say 47.5. And then we'll also change the Y. That looks good about there. 32.25. And that makes a good little position for our cutout. And we'll call it good there. So basically, we've got to duplicate the same thing. Changing it from here is fairly straightforward. We basically just have to take the position of that cylinder and apply it to a few others. So let's say the Z on that guy is 34.5. Change that. Let's take the X on this and move him over to where he needs to be. And then the Y will be the opposite. So the absolute value of that guy. And now we've got a nice little cutout over there. Same thing here. Now we know that we've got the Z values here. Same thing here. We know that the X is going to be the opposite for both of these. So let's go ahead and apply that to both of them. And then we just need to get the Y positions and copy this for both of these guys. So one of these guys will be here, and the other one of these guys will be here. And now we've got this perfectly aligned cutouts for the box drill holes. Alright, so then let's do the actual cutouts. We'll add a modifier, a Boolean. We will select the first cylinder. And let's make all of these cylinders, the viewport, just wires. So wire, 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 wire. And then from here we can add in the other Boolean modifiers. Let's duplicate and duplicate. Cylinder 2 and cylinder 3. So now we can actually see the cutouts for these there on the edges. Now we've got to do the same thing here. Let's add more Boolean modifiers. Duplicate, duplicate, and duplicate. The first one, cylinder. The second one, cylinder 1. The third one, cylinder 2. And the fourth one, cylinder 3. If we go ahead and hide this guy, we should now be able to see the cutouts within our walls. And as you can see there, we can see those cutouts now. So that is it. Now we just need to apply all these modifiers, do a little bit of cleanup, and export these models to be STL files so we can actually print these on our printer. That's all I got for you guys. Please like the video and subscribe to the channel if you haven't already. We've got more content coming. We've got about one more day to get this project done, so we'll see, fingers crossed, if we can get it done in time. Follow along for more content, and I hope to see you guys in the future.